going to continue our discussion of slope that we started yesterday. So when you look at this sign, what do you think the meaning of that would be? It shows a truck going downhill, which would indicate that, right, there's a steep road ahead. And when we see something like this, this indicates how steep the road actually is. That 7% means that every time the road drops 7 feet, right, that's your vertical movement, you've moved horizontally 100 feet. And that should sound kind of familiar, right? That's our definition of slope from yesterday, is it's a ratio of your vertical movement compared to your horizontal movement. So slope really just tells us how steep is a line. It's a numerical description of how steep a line is. And it can be expressed in different ways. So we did some of this in our notes yesterday, right? We've seen all three of these. We've got our mathematical formula, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. We can think of that as rise over run, where it's the vertical change. That is, how much are we moving up and down compared to our horizontal change, right? How much are we moving right or left? And if it's moving upward to the right, we say it as a positive slope. If it's moving downward as we move left to right, then we say it as a negative slope. We also talked about, depending on how you're determining slope, are you looking at a graph, are you looking at ordered pairs? Sometimes some definitions are more convenient or more useful than others. When we have a picture of slope, the rise over run definition really is the easiest one to use. We're talking about, again, moving vertically compared to how much are we moving horizontally. So if I wanted the slope of this line, I'm trying to get from one point on the line to another. So I'm going to start by moving vertically. How many squares or how many spaces did I move? And in this instance, I moved vertically 3 spaces. And then I compare that to the run, or how much did I move horizontally? In this case, it was 6 spaces. So the slope of this line would be 3 over 6, or if we simplify it, 1/2. So 1/2 is just, again, a numerical way to describe how steep this line is. It's also a positive slope, right? We can see that the line moves upward to the right, and when I counted my spaces, moving up on the coordinate plane would be positive, moving right on the coordinate plane would be positive. So my slope ended up being a positive 3 over positive 6, or positive 1/2. When we're given ordered pairs, then the formula really is easiest to use. So the reason we had y sub 2 and y sub 1 is because we've really got 2 y terms here, right? Negative 2 and 1. And we really have 2 x terms, negative 2 and 4. Now, which one of those really is y sub 2 or y sub 1 really doesn't matter. What does matter is that we're consistent. So in this particular example, they're going to use the second ordered pair to be their y sub 2, which means the second ordered pair is also going to have to be my x sub 2. So I'm just going to plug those numbers into the formula. I'm going to plug 1 in for y sub 2, and I'm going to plug negative 2 in for y sub 1. And do the same with x, right? My 4 is going to be x sub 1 or x sub 2. My negative 2 is going to be x sub 1. And I'm just going to compute that formula. 1 minus negative 2, remember with 2 negatives in a row, I'm really going to add here. It's going to give me 3. And 4 minus negative 2 is going to give me 6. You'll notice I got the same slope as I did on the last slide. And there's a reason for that. This was really the same problem, right? We're looking at this ordered pair, 4, 1, and we're looking at this ordered pair, negative 2, negative 2. It was really the same problem. It's just one I had the graph to look at, and the other one I was using the ordered pairs. So then I used the formula to determine slope instead of counting squares on the graph. So we get the same answer for both. We really were doing the same problem, just 2 different ways. So if I wanted the slope of this line, because I'm looking at ordered pairs, again, again, I would use the formula. So what do I want to call x sub 1 and x sub 2, y sub 1 and y sub 2? It doesn't really matter. I am this time going to call my first ordered pair y sub 2. So I'm going to take 5 minus 4 as my numerator. So the 5 was y sub 2, which means 3 has to be x sub 2. Point is, I have to be consistent, right? So now I'm going to take 3 minus negative 1 in my denominator. So 5 minus 4 is going to give me 1. 3 minus negative 1. I've got 2 negatives there, so I'm really going to add. Going to give me 4. So the slope of the line through those 2 points should be 1/4. Now here's another way I like to think of that. Instead of looking at the formula, if your points are fairly close together, just look at the difference between them. Look at my 2 y terms. And again, be consistent in the way you do this. Change in y is going to go on top. So I'm going to draw this arrow on top. How much did it change to get from 4 to 5? Well, that's a change of 1. Now look at the x terms. How much did it change to get from negative 1 up to a positive 3? Well, that would have been a change of 4. And again, I'm going to get the answer 1/4 for my slope. So let's try that again. Let's find the slope of the line that goes through these 2 points. So if I use my formula, we're going to plug in some numbers here. So they used 1 as their y sub 2. And they used 3 as their y sub 1. That's where 1 minus 3 comes from. They used, now be consistent, right? If I used 1 as my y sub 2, I have to use 2 as my x sub 2, which means negative 5 is going to be my x sub 1. So on the bottom, I ended up with 2 minus negative 5. By the time I simplify that, I'm going to get 1 minus 3, or negative 2 over 7. Let's do that a little bit differently. Instead of using the formula, again, let's just look at the difference between my x's and my y's. So if I went from, when I look at my y's, I'm going to put that arrow on top, 3 to 1. That is a difference of negative 2. Right? I dropped 2 or went down 2. So my change in y is going to be negative 2. Now look at my x terms. I went from a negative 5 to a positive 2. That would be an increase of 7. So that's my change in x. So I come up with the same answer, right? The slope of that line is negative 2 over 7. So if we wanted to determine the slope of the line here, I don't really have any specific points. So I can really pick any points on this line that I choose. Looks like it goes right through a set of ordered pairs there. Looks like I could use that one. Looks like I could use this one. I could use this one. It really doesn't matter which ones I pick. As long as I simplify my answer, I should get the same thing. Now, because I have a graph to look at, I'm going to count squares. We always want to look at the vertical movement first, right? So let's go from this dot to this dot. I'm going to go up 2 spaces, so that's my change in y. And then I'm going to go left 1 space. Well, if we are looking at the coordinate plane, anytime we go left, that's going to be negative. So I went up 2 spaces, left 1 space. Well, negative 2 over 1 would simplify to negative 2. Let's say we picked 2 other dots, though. Let's say I didn't pick those. Let's say I picked this dot here and this dot here. So this time I went up 6 spaces and then left 3 spaces. Well, by the time I simplify it, I'm going to come up with the same answer. Because it's a linear graph or a straight line, by the time I simplify, I should end up with the same answer. So -2 is the solution, or the slope of that line. So I just found some points on the graph. I used the definition of rise over run, and then I simplified my answer, and that's where we came up with -2. And if you'll notice, as I move left to right, that line is going down, so a slope that's negative makes sense in this situation. And if you remember from yesterday, a slope that's horizontal would be a slope of 0, because it doesn't have any rise. We're not going up or down as we move to the right. And when I look at a vertical line, that's a line that's so steep we can't describe it numerically. I can't give you a number that describes how steep something is that moves straight up and down. So in this case, we say that has a slope that's undefined. A good way to remember that is the use of Mr. Slope Guy. So on your note sheet, we're going to create a Mr. Slope Guy. And I'll kind of describe to you where this comes from and how this can help you remember slope. So we're going to start with Mr. Slope Guy's eyes. So you'll notice that one of his eyes is a positive sign. So I'll just highlight these in red. And above that positive eye is an eyebrow that has a positive slope, right? It's moving up as we go to the right. His other eye looks like a negative sign, and above that, his eyebrow is a line that's slanted downward, right? It's a line with a negative slope. So let me get my extra lines off here. Those eyes can be used to indicate, okay, positive slope on the left, negative slope on the right. Now let's go to his nose. His nose consists of a vertical line, or a line that's moving straight up and down. And the bottom of his nose is shaped with what looks kind of like a U. Well, that U is short for undefined. So we can use that to help us remember that a vertical line has an undefined slope. And then Mr. Slope Guy doesn't appear to be real happy. So his line consists of a horizontal, or his mouth consists of a horizontal line. And these two little dimples, which look like zeros, can help us remember that, hey, horizontal line, slope of 0. Nose, vertical line, is undefined. And then the eyes, positive slope on one side, negative slope on the other. If this helps, remember the word Buck's-Hoy. Vertical lines, undefined slope. X equals a number, right? So you have something like x equals 5. This is the equation of the line. Horizontal lines, 0 slope, or y is equal to a number. But I think Mr. Slope Guy is probably more useful than that.